Stop scrolling right now because what NOAA scientists just discovered about this week's weather pattern is genuinely unprecedented in modern forecasting history. We're not talking about another winter storm. We're witnessing something that has NOAA's most experienced meteorologists using words they rarely deploy: significant model disagreement, highly unusual uncertainty, and atypical La Niña behavior. At the 4-minute mark, I'll reveal the exact atmospheric mechanism causing this chaos. By minute 8, you'll understand why your local forecast keeps changing every 6 hours. And at minute 12, I'll show you the 3 regions where this uncertainty creates the most dangerous conditions for the 15 million Americans traveling this weekend. Here's a number that should immediately grab your attention. As of Thursday, January 9th, 2026, NOAA's European and American forecast models are showing disagreement patterns not seen in a weak La Niña winter in over a decade. The European ECINS model is projecting temperatures 8 to 12 degrees colder than the American GEF's model for the same week 2 period. When the world's 2 most sophisticated weather prediction systems can't agree on basic temperature trends just 10 days out, that tells you something fundamental is broken in our atmospheric patterns. Let me be absolutely clear about what makes this situation genuinely unprecedented. It's not the storms themselves. We've seen atmospheric rivers before. We've tracked bomb cyclones. We understand polar vortex disruptions. What's unprecedented is the combination and the timing, creating a weather pattern so complex that NOAA's Climate Prediction Center issued an unusual statement on January 8th, acknowledging considerable uncertainty in their extended forecasts. These are scientists who forecast weather for a living, and they're telling us the atmosphere isn't behaving according to established patterns. Here's what's actually happening right now across North America, and why it matters for your planning over the next 2 weeks. 3 separate weather systems are interacting in ways that defy typical January La Niña behavior. First, back-to-back atmospheric rivers slammed California from December 30th through January 4th. The second system packed integrated vapor transport values between 800 and 1,000 kilograms per meter per second. For context, anything above 750 is considered a strong atmospheric river capable of catastrophic flooding. Northern and central California saw over 7 inches of rain in 72 hours, with mountain snow measured in feet, not inches. But here's where this story diverges from typical West Coast winter weather. Simultaneously, a bomb cyclone developed over the Great Lakes on Monday, January 6th, with atmospheric pressure dropping rapidly enough to meet the technical definition of bombogenesis. This system brought blizzard conditions to Michigan's Upper Peninsula, ice storm warnings to upstate New York and Vermont, and winter storm warnings from the Midwest through the Northeast. Over 114 million Americans found themselves under high wind alerts as Arctic air plunged southward behind this rapidly intensifying system. Now, if you're thinking this sounds like normal winter weather for early January, you're partially right. What makes this unprecedented isn't any single storm. It's what NOAA scientists discovered when they tried to forecast what comes next. The La Niña pattern that should be guiding our winter weather is behaving erratically. According to NOAA's latest ENSO update from January 5th, we're experiencing the weakest La Niña event in recent memory, with a 68% probability of transitioning to ENSO-neutral conditions sometime between January and March 2026. Weak La Niña winters are notoriously difficult to forecast because they lack the strong atmospheric signals that help computer models predict weather patterns. But this year we're seeing something meteorologists rarely encounter. The jet stream is oscillating wildly. The polar vortex disruption from December's stratospheric sudden warming event is still influencing circulation patterns, and Pacific moisture is interacting with Arctic air in ways that don't fit established La Niña templates. Let me show you exactly why NOAA's forecasters are struggling with this pattern. In a typical strong La Niña winter, we see consistent blocking high pressure in the North Pacific, a well-defined trough over western Canada, and a predictable jet stream configuration that channels cold air into the northern United States while keeping the southeast and southwest warmer and drier. But right now, none of these typical markers are holding steady. The blocking patterns are shifting every 3 to 4 days. The jet stream is taking configurations that computer models don't recognize from historical La Niña data. Arctic air masses are penetrating further south than weak La Nina patterns typically allow. This creates a forecasting nightmare that directly impacts your life if you're making travel plans, scheduling, outdoor work, or trying to decide whether to stock up on heating fuel or storm supplies. When NOAA's Weather Prediction Center issues a forecast discussion that explicitly states significant model differences, and due to significant differences, no associated hazards are specified, that's meteorologist speak for, we honestly don't know what's coming with enough confidence to warn you. Here's the timeline of what we know with high confidence, followed by what remains dangerously uncertain. Through this weekend, January 10th through 12th, high pressure will dominate the western and central United States, bringing above average temperatures to the Great Plains and Midwest. This part of the forecast shows strong model agreement. The Pacific Northwest will see continued precipitation as moisture from those atmospheric rivers lingers, with the northern Rockies and Great Lakes receiving above normal precipitation. Again, high confidence. But here's where confidence collapses and uncertainty takes over. For week 2, approximately January 13th through 20th, the European and American models diverge dramatically. The European ECONS model shows amplified troughing across the interior United States, favoring a much colder pattern with potential for significant winter storms, tracking from the Rockies toward the Great Lakes and Northeast. The American GEF's model maintains ridging, suggesting continued above-normal temperatures and limited storm potential. These aren't minor disagreements. We're talking about temperature differences of 10 to 15 degrees and completely opposite precipitation scenarios for the same geographic areas on the same dates. For the 30-plus demographic watching this, you understand what forecast uncertainty actually means for your life. It means you can't confidently plan that weekend trip to visit family. It means construction projects get delayed because you can't trust the weather window. It means heating bills become unpredictable because you don't know if you're facing Arctic blasts or mild weather. It means school districts can't plan schedules, airlines can't optimize routes, and emergency management can't pre-position resources. Economic productivity suffers when atmospheric chaos replaces predictable patterns. Now let me reveal the 3 specific regions where this unprecedented uncertainty creates the most dangerous conditions over the next 10 days. Region 1. The Ohio Valley through the Mid-Atlantic, including Pittsburgh, Columbus, Cincinnati, Indianapolis, and extending through Philadelphia and Washington, D.C. This corridor sits directly in the zone where the European and American models show the largest disagreement. Depending on which model verifies, this region could see either continued mild temperatures with occasional rain showers or a significant ice and snow event sometime between January 14th and 18th. The difference between these scenarios is not trivial. One means normal winter operations. The other means potential infrastructure failure, or dangerous travel and power outages affecting millions. Region 2, the northern and central Rockies, including Montana, Wyoming, Idaho, and northern Colorado. This area faces uncertainty related to mountain snow accumulation and avalanche danger. If the European model's colder, stormier pattern materializes, ski resorts could see extraordinary snowfall totals exceeding 3 to 5 feet over a week-long period. That sounds great for skiing, but it also means extreme avalanche danger, closed mountain passes, and isolated communities cut off from supplies. If the American model's milder ridge pattern holds, snowpack remains below normal, water supply concerns persist, and the ski industry faces economic challenges. Region 3, and this might surprise you, the Deep South, including Tennessee, Alabama, northern Georgia, and the Carolinas. These states rarely prepare for significant winter weather, which makes forecast uncertainty particularly dangerous. If colder air penetrates further south than the American model predicts, we could see ice storms affecting Atlanta, Nashville, Birmingham, and Charlotte. Infrastructure in these cities isn't designed for sustained ice accumulation. Power grids fail. Water systems freeze, emergency services become overwhelmed, and because the forecast confidence is low, residents aren't receiving clear warnings to prepare. Let me explain the atmospheric mechanics behind why this pattern has become so chaotic and unpredictable. It starts with the stratospheric sudden warming event that occurred in December 2025, When the polar vortex destabilizes at high altitudes, it sends ripple effects through the entire atmospheric column. Normally, these effects propagate downward in predictable ways over 4 to 6 weeks, but this year the downward propagation has been irregular and inconsistent. Some regions experienced the expected Arctic blasts. Other areas that should have seen extreme cold remained mild. Simultaneously, the weak La Niña pattern in the Pacific is failing to provide the strong teleconnection signals that help guide weather patterns across North America. La Niña typically influences the position and strength of the Pacific jet stream, which in turn affects storm tracks, temperature distributions, and precipitation patterns from coast to coast. But weak La Niña events produce weak signals. Computer models struggle because they're trained on historical data that predominantly features either strong La Niña, strong El Niño, or clear neutral conditions. This marginal, transitioning state creates massive uncertainty. Add to this the fact that ocean temperatures along the west coast remain above normal despite La Niña conditions. Warmer ocean surfaces provide additional energy to atmospheric rivers and coastal storms, intensifying precipitation beyond what typical La Niña patterns would suggest. The models understand individual pieces of this puzzle. What they're struggling with is how all these pieces interact to produce the final weather outcome. Here's what separates professional meteorological analysis from social media weather hype. Professionals acknowledge uncertainty. They communicate confidence levels. They explain why forecasts change. Amateurs make bold predictions, ignore model disagreement, and create false certainty that can actually endanger lives. When NOAA scientists tell you they're seeing unprecedented model disagreement, that's not weakness. That's intellectual honesty about the limits of current forecasting technology when confronted with genuinely chaotic atmospheric states. So what should you actually do with this information? First, understand that flexibility is your greatest asset over the next 2 weeks. If you have travel plans, build in buffer time and have backup options. Monitor forecasts daily, not just once when you initially make plans. Conditions will change as models begin converging on solutions, or as actual observations provide data that helps constrain the forecast uncertainty. Second, prepare for the worst plausible scenario in your region while hoping for the best. If you're in the Ohio Valley or Mid-Atlantic, that means having emergency supplies ready in case that European model's ice storm scenario materializes. Stock non-perishable food, water, flashlights, batteries, and alternative heating sources. Charge backup power banks. Fill prescriptions. These preparations cost you nothing if the mild scenario plays out, but they could save your life if the severe scenario unfolds. Third, if you're in the Rockies, respect avalanche danger and mountain travel warnings. When snowpack is already unstable and models can't agree on how much additional snow is coming, mountains become genuinely deadly. Ski within your abilities. Check avalanche forecasts obsessively and avoid backcountry travel unless you have professional training and equipment. Fourth, if you're in the Deep South, take winter weather possibilities seriously even though they seem unlikely. Prepare as if you might lose power for 2 to 3 days. Insulate pipes. Know where your main water shutoff is located. Have alternative heating plans that don't involve burning charcoal or running generators indoors. Carbon monoxide poisoning kills more people during southern ice storms than the cold itself because residents aren't familiar with safe emergency heating practices. Now let me address what this pattern means for the rest of winter and early spring 2026. The transition from weak La Niña to ENSO-neutral conditions typically produces highly variable weather patterns. Some weeks will feel like winter, other weeks will feel like early spring. This variability makes long-range planning extremely difficult for agriculture, construction, energy sectors, and transportation logistics. Heating degree days become unpredictable, affecting energy demand forecasting. Freeze-thaw cycles accelerate infrastructure damage to roads and buildings. Snowpack accumulation patterns affect water supply projections for the entire spring and summer growing season. For February and March, NOAA's extended forecasts show increased uncertainty continuing. If ENSO-neutral conditions establish quickly, we could see storm tracks shift, potentially bringing more moisture to drought-affected areas in the southwest and southeast. If La Nina hangs on longer than expected, the current dry pattern across the southern tier could persist, exacerbating wildfire danger and water supply concerns. The honest answer is that NOAA scientists don't know with high confidence which scenario will play out, and that uncertainty itself is unprecedented for this point in the winter season. Here's the broader context that makes this situation particularly challenging for the millions of Americans over 30 who remember winters when forecasts were more reliable. Climate patterns are shifting in ways that make historical data less useful for predicting future conditions. The past is no longer a perfect guide to the future. Weather events that were once rare are becoming more common. Atmospheric states that used to be clearly defined are becoming muddier and more transitional. This doesn't mean meteorology has failed. It means the atmosphere is evolving faster than our forecasting systems can adapt. NOAA scientists are responding by developing new forecasting techniques, incorporating machine learning alongside traditional physics-based models, and increasing the resolution of computer simulations to capture smaller-scale atmospheric features. But these improvements take time to develop, test, and implement operationally. In the meantime, we're living through a period where forecast uncertainty is higher than we'd prefer, especially during high-impact weather events that affect millions of lives and billions of dollars in economic activity. Let me share something crucial about how to interpret forecast changes over the coming days. If you check the forecast Monday and see mild conditions, then check Thursday and see a major winter storm, that doesn't mean meteorologists are incompetent. It means new data arrive that help models resolve the uncertainty. The European and American models will either converge toward a common solution, or actual observations will prove one model right and the other wrong. Either way, forecast confidence will increase as we get closer to the event window. What you should watch for are trends in the forecast, not individual model runs. If consecutive forecast updates keep trending colder and stormier, that suggests the atmosphere is organizing toward the European model's solution. If updates keep trending milder, the American model is likely correct. If forecasts whipsaw back and forth with no clear trend, that tells you uncertainty remains high, and you should maintain maximum preparedness until the situation clarifies. For critical decisions like whether to travel during the January 14th through 18th period, wait until at least January 11th or 12th before finalizing plans. By then, we'll be inside the 3 to 5 day window where forecast confidence increases dramatically. Models that currently disagree on temperature by 15 degrees should converge to within 3 to 5 degrees. Precipitation scenarios that currently range from nothing to major winter storm should narrow to actionable forecasts. Here's something that almost nobody talks about, but that profoundly affects your daily life. Forecast uncertainty costs the American economy billions of dollars annually in lost productivity, inefficient resource allocation, and suboptimal decision-making. Airlines cancel flights too early or not early enough. Retailers stock the wrong seasonal merchandise. Construction companies idle crews when weather turns out fine, or push forward when conditions deteriorate. Energy companies struggle to predict demand spikes. All because atmospheric chaos makes 7 to 14 day forecasts unreliable. NOAA understands these economic impacts, which is why they're transparent about forecast uncertainty rather than pretending they have confidence they don't possess. The Weather Prediction Center's discussions are written for professional meteorologists and emergency managers who need unvarnished truth, not reassuring certainty. When they say considerable uncertainty or significant model disagreement, they're giving critical stakeholders the information needed to make appropriate risk management decisions. As we move through mid-January, pay attention not just to your local forecast, but to the broader pattern evolution NOAA is tracking. The position of the jet stream determines whether you get cold or mild, stormy or calm. The strength of blocking patterns in the North Pacific and North Atlantic influences how long particular weather regimes persist. The phase of the Madden-Julian oscillation affects whether tropical moisture reaches the continental United States. These large-scale features drive the day-to-day weather you experience, and understanding them helps you anticipate changes before they arrive at your doorstep. One final critical point before we close. This unprecedented pattern creates opportunities for dangerous weather myths and misinformation to spread rapidly on social media. You'll see posts claiming secret government weather modification. You'll see alarmist predictions of the next ice age or catastrophic storms with no basis in actual forecast data. You'll see amateur forecasters making confident predictions that contradict NOAA guidance. Ignore all of it. Trust NOAA. Trust the National Weather Service. Trust your local National Weather Service forecast office. These are the professionals with the training, tools, and accountability to provide accurate, life-saving weather information. The atmosphere doesn't care about our need for certainty and predictability. It follows physics, not our preferences. When multiple complex factors interact in unprecedented ways, honest scientists acknowledge uncertainty while continuing to provide the best possible guidance based on available data. That's what NOAA is doing right now. That's what you should expect. And that's why this pattern, more than any particular storm, deserves your attention and preparation. We'll continue monitoring the situation closely, updating you as model confidence improves and the forecast becomes clearer. Check back daily for updates because in a pattern this chaotic, yesterday's forecast may not reflect today's reality. Stay prepared, stay flexible, and trust the science even when the science is telling you it doesn't have all the answers yet. That honesty might be uncomfortable, but it's what keeps you safe when the atmosphere decides to throw us something we've genuinely never seen before.